All right. Hello, everybody, and welcome to our webinar today. We are at the top of the hour, so we're going to go ahead and kick things off. My name is Gabe Prado. I'm a Director of Marketing at Cognite, and I'll be moderating the session today. I'm really excited to share this presentation. We've got some great speakers. The topic today will be around data discovery and how it's becoming more and more simple for industrial operators. We've got a great panel today with Michele Goetz, VP Principal Analyst with Forrester, and then Cognite's Chief Product Officer, Mo Tanabian. We'll have two presentations, one covering industrial data ops and the implications for generative AI, and then we'll go into some more of the reality for industrial operators, talking about how to make generative AI actually work for industrial operators. I'm going to hand it over to our panelists, Michele, to kick things off.
Great. Thank you for having me. We're going to talk about, number one, data ops really is more important than ever. And I hope that, by the end of this presentation, you understand not only that that's true, but why. We're also going to take a look at the fact that generative AI is really putting more pressure on your data ops competencies. So what else do you need to be thinking about? And how do you apply data ops when generative AI comes into the mix? And then at the end of the day, what do you do? How do you get started? So with that, let's talk about why is it more important than ever? Well, really, it comes down to the fact that in the past, the way that we've engaged with computers and understood our systems is writing a bunch of code. We're speaking in computer language. But what generative AI is allowing us to do is now have computers understand us. We can have a dialogue. Now, this becomes really important because what does dialogue allow you to do? It's much more flexible. It has more fluidity, and it has more bidirectional sharing of information and comparing of information. And you want to be able to navigate through a whole host of contexts and concepts and things that you need to do in your everyday life, but more importantly, in our work lives. And so this is where we need to start. We need to think about our data because it's the data underpinning that is both giving the option to have this dialogue and understand what's going on in our systems, having our systems communicate back to us in something that we understand, and then also ensuring that we're pulling all these pieces together, that mapping, the metadata. So ultimately, what we want to be able to do when we're thinking about data ops is putting that discovery and understanding around what is that critical data that really brings that conversation to life, that helps us understand our ecosystems, especially when we're looking at highly complicated industrial environments. We need to understand where data is coming from. We've got a highly distributed environment of the data itself. And then there's a lot of input and output streams from our AI models, generative AI being one of those capabilities. And it's not just sitting in some central cloud location. Yes, part of our environment is running there, but we're also looking at sensors. We're looking at our gateways. There's dedicated pipelines in a lot of our edge environment. We want to know, can we trust this data? Is it of high quality? Is it meeting the thresholds that we've set so that we can trust that information to know how well are our industrial systems performing, or when we need to be thinking about some preventative maintenance so that we don't have downtime. And then lastly, we need to put this back into the context of our human language about what we're thinking about when it comes to our industrial environments. If you're in oil and gas, what is a rig? What is a drill head? What are our shipping schedules related to? And so it's those pieces that help contextualize what's happening, the state of our data, and help us to prioritize where we need to focus next. And that's ultimately what data ops is about, right? It's about thinking of the ways that data helps enable our objectives. Now, we've generally thought about the automation side of it. What is that foundation that we need for our data? And how do we operate in automated processes, for example? It's about the bits and bytes of the system. We thought about it in terms of analytics. But now with generative AI, we're also thinking about it in terms of the experience. And that is actually more heightened because we had to think about What was the analytic experience before? How easy was it to work with and navigate our data? And then ultimately, we want the competencies to develop the capabilities that help us get value from the information. We want to create capabilities that are composable, that we can, put together so that we can deliver on these solutions. And then ultimately, I talked about trust before. How do we trust these systems? How do we trust our data? It's ultimately coming down to governance. We need to govern by design. These are both business requirements so that we can have confidence in our information, in our solutions to drive higher adoptions of our industrial data-driven capabilities. At the same time that we need governance back down in our systems, that our data engineers, data management teams, and even the architects really need to understand how data is flowing in the environment and is it adhering to the requirements that we set in place. In order to make this possible, where do we begin? We think about our use cases. We think about, if we're going to build something, we're going to save it, we're going to put it in a library, we're going to offer it up to share it, give us that launch point for the next thing, move faster with new use cases and optimizing our systems. That helps us deliver at scale. If you can do it faster, more efficiently, you can put more out there, and it allows us to distribute those capabilities across a wider landscape, not just of use cases, but our systems themselves. And then, like I said, you're governing by design. It's just part of the ethos of what you do. Now, we've talked a little bit about generative AI and haven't gone down into the details yet. So why is it putting so much pressure on data ops competency? Well, let's think about this. If we look at the oil and gas landscape, it's one thing to do the extraction. It's another thing to turn that into the revenue and the profits that we want for our business. And so when you're at the platform, certainly there's AI functionality and data functionality that is telling you how you're refining that oil and basically putting it through a manufacturing process and then doing that to the specifications that your customers have and are going to send their tankers and pick that up. And then you have schedulers who are thinking about, what should I be processing on that manufacturing line? How do I schedule for where those shipping containers, those tankers are coming from and when they're going to arrive? And then you have to think about what are those price points and relegate that back to those contracts. That is super complicated. And in pre-Gen AI days, we probably took data and analytics and AI and pointed them in different directions. On the manufacturing piece, we're thinking about understanding our processing functionality, dealing with preventative maintenance, things of that nature. Scheduling, we've got scheduling, assistance and simulations to help us figure out how to, rejigger our scheduling and our pickups for a particular day and time. And then we're manually thinking about how to connect the dots between those two things and still work towards those pricing and profitability levels that we need. Well, what generative AI is doing is helping to span the full end-to-end process of going from raw material to getting it in the hands and delivery for the full fulfillment of the oil that's being picked up. Now, that's really important because what does that mean? It means that we're using generative AI now. And actually what one oil and gas firm is doing is that they're overlaying a conversational interface to have those schedulers ask the right questions that matter to them to help them fulfill what their duties are and getting the oil to the customers on time. And instead of just looking at schedules, now generative AI spans across the whole ecosystem to really understand where things are at and take into account not just what has been planned, but what are the conditions of other types of dependencies, other types of, where customers are at, things that might be happening outside that are affecting pickups, but also thinking about what is the optimal way to adapt the production line to that. And then giving that information to the schedulers, the human in the loop, to determine, I like that direction, or maybe we can rework it in this way and will be more optimal, as well as the fact that generative AI is doing this in context of what is that pricing and profitability component doing. So it's human centric because human in the loop asking the questions. It's conversational because generative AI is helping that oil and gas company kind of navigate in a more natural way around questions and answers, questions to the system maybe even questioning the operator or the scheduler. It's allowing you to explore different options. And really, it's actually acting as an augmented employee, another actor in the mix. So that creates part of this complexity. We're navigating across the entire ecosystem and set of use cases that are going on within our organization. So this really starts to bring in these new challenges. So if we take that oil and gas, company's example, they've got to be thinking about not just the unstructured information around scheduling and pricing and contracts that has been put into ERP systems and so on. They have to think about maybe some of the other types of information that's going on. How is it taking a look at what are the visual conditions? Are there geospatial conditions that need to be taken into account? Is there news material that's talking about, issues or down issues in canals, for example? So how do you combine all of that information, making that feel seamless in your environment? The fact of the matter is we haven't always thought about preparing all of this information for a generative AI system or for a holistic AI system. So we have to go back to the well and think about, how do we shape our data? How do we define it? How do we govern that information so that it is ready and available, and putting the right things into place? And that means that not all data is probably governed if you also got to prepare it for use. And then sometimes you have limited visibility. We have pretty good granular visibility into our structured information. We have pretty good visibility into our unstructured information. But when you're having to navigate through layers upon layers, which could be thousands of layers deep, or even hundreds of layers deep, it's really hard to understand and interpret. Why did generative AI come up with the answers that it did? And so what is the way that you get better visibility into that training? How do you put the appropriate constraints in to ensure that you're getting the right information? And how do you start tuning and adapting, not just from a data science training perspective, but that you're managing that information back to what your user is expecting to drive that adoption? And ultimately, within industrial systems, as we've talked about, we're still doing this in a highly complex, probably one of the most complex ecosystems of traditional administrative, data environments and our IoT and processing environments. And our models are operating out in the edge, and they're also operating at the core in our cloud. And so we're having to really think about, how do you orchestrate and coordinate all that information so that we can get on the same page, synchronize that information temporally, so that we can get to the point where we have confidence in the decisions that we're making. So ultimately, let's get back to data ops. Why does data ops need to really be in place? How do you up the game here? Well, we want to make sure that for generative AI, it's focused on 4 areas. There's trust in the data. That's just sort of ground level. We need to know that the data is working for our use case. We need to protect this information. There's security threats, there's state threats, there's just random leakage accidentally by our employees. We want to be very mindful that we're maintaining control of our information. We operate in a very regulated industry. So we have to assure that what we're doing with our information still adheres to those regulations, and then putting a new lens on it from the point of view of what generative AI is going to add on top. As we start to mix and match human decisioning with guidance from our AI system, regulators are looking very closely at that point of intersection. You're not off the hook if the model tells you to do something. Humans have to be in the loop. And so regulatory compliance has to be part of the innate requirements and capabilities of your data systems. And then lastly, responsible AI. We want to do the right thing. We all have, goals for reducing our carbon footprint, broader ESG aspirations and objectives. We are reporting those out to the market. We want to show that we're good citizens in the way that we're managing our industrial environments, particularly from an oil and gas perspective. And so as we break this down, how do we look at data ops within those categories? So let's first start with really set that domain, understand not just what data is available and is like moving through the ecosystem, understand what are you trying to do? The oil and gas example I gave was the endpoint of we need to fill tankers. I have a scheduler who's trying to figure out what is the optimal way to do that. And from that point, business capabilities, really matter here. That's your context. You'll break that down into use cases. Now you can start thinking about where are the trusted sources of information? What is the state of that data? And then how are you providing the appropriate access? The concepts are there. Obviously, understanding the capabilities and use case, tell you how to build the context into the data, putting the right semantics with ontologies in place, the proper policies and governance, as we talked about, in security, regulations, and social responsibilities. And obviously, what's the environment that the information is going to be operating in, understanding that technical platform and ecosystem. Inferencing. This is where it gets a little bit more interesting because we now need to think on the back end of how is the system coming to understand and interpret the human natural language request? How do you understand and interpret intent? This is both to satisfy what you need, but this is also to ensure that maybe there's a bad actor doing things that they shouldn't be doing, either through an automated process or maybe it's an actual worker. We want to be careful and mindful of that. So now there's more inferencing, not just on a straight query, but actually the question that's coming in. And that interpretation is as much about interpreting the question and managing that data as it is interpreting that back and mapping it to the information and the capabilities that we're going to provide. Governance gets imposed in there. I talked about that from a request perspective, and then constantly coordinating that conversion between requests coming into the system to get to the information and insight, and then how that information and insight is crafted and brought back to that human as they're making their decisions. And ultimately, that comes down to the hardcore engineering component of data ops, which is how do you even construct this environment? Putting a proper control plane in place for access, ensuring that you have the right integration and interoperability architecture for those retrievals, your ability to compose services that support that agenda, and then ultimately, how do you best respond? This is going to span the engineering competencies, how you specialize your generative AI capabilities, the way you observe what the system is doing, and ultimately giving you the opportunity to improve. So ultimately, what's happening here? Number one is data ops helps you navigate this hyper-federated landscape. This is an example of sort of an abstraction of a RAG architecture that Gen AI overlays on top of your systems. And what do you have to think about first? I need a data product. We've been talking about data products for a while. What are those components? We talked about composability that you're building so that you can bring them together. And how are those linking to your business outcomes? You want governance as code. It's not good enough just to say, I've got a policy and I'm just watching things. You have to be able to apply that policy as an actual control where most appropriate. So as code means we're federating our governance capabilities, putting it in the right place for the right time. And then what helps us navigate what feels like seemingly chaos? What are the architectural standards for these systems against those business capabilities and use cases that we're applying this to? So what do we do to get started here? The first thing is get back down to the use case, but look at it a little bit more holistically. Think about where can you get started with generative AI and those data capabilities easily and quickly, proving this out. How does that give you the opportunity to move to another ambition within the same use case or for a new use case? So maybe you start with helping just to understand scheduling. That begins the first use case. The next piece is taking scheduling and tying that to other aspects of either supply chain or of manufacturing, and so on and so forth. So we're going to move in a more organic method in the way that we think about how we build out our roadmap of enablement, breaking it down. It's going to feel like your agile development and your CI/CD, right? So this should feel familiar, but it's use case oriented because you need that context. But at every step of the way, as you evolve, you always have to be thinking about, yes, I have a goal in mind. We need to drive towards these types of cost reductions or revenue increases. But at the same time, I got the regulator on my back. I'm concerned about security. I've got other types of ethical considerations and carbon footprint considerations that I need to put into place. So how do we balance the levers in these, at these use case decisions to ensure that we're at a balanced point to get the right outcomes and value from our data that we want? We want to prepare data appropriately. Do this in the context of really understanding that use case first, that context. This is really where the domain definition comes in, that profiling and lineage that we talked about in understanding your data and discovering information. And this is where you're going to know what is the governance that needs to be put into place. Prototype it, get an understanding of it. Generative AI is kind of funky because you don't always know what you're going to get until you can mess around with it. It's not as black and white as you see in other types of technology. So make sure you've got a good playground, both for you on the technical and data side, and then bring your business partners along and help them understand and vet this. And that's the point where you're going to get good adoption. Test it, but test this side by side with the experts before you fully roll it out. Test it side by side and compare it to what you've already developed. Is it giving you the benefits that you expect, or is there room for improvement to optimize within there? So benchmark ahead of time and then measure both sides in parallel as you push that out. And when you get the let's go from those experts who are helping you through that initial process, now you can start to push this into production and scale. So with that, thank you very much. I'm hoping you got some, good information about the link between data ops and generative AI. And now I'm going to pass it over so that Mo can talk a little bit more about the specifics here.
Awesome. Thanks, Michelle. That was a great foundation for the section that I'm going to talk about. So basically, what Michelle said very resonates and is a great segue to what I'm going to talk about, which is how do we create a reliable business value adding set of solutions and use cases with generative AI. And that requires this magic of combining generative AI, particularly large language models category, with the foundational data piece, which I characterize as knowledge graphs. I thought this is a good way of getting us started, and just making sure if you add AI to any project, very likely you're going to get some attention from your CFO and your CEO. So just a hint. All right. A little bit about background about me. I'm the Chief Product Officer for Cognite. I lead product management, software engineering, and program management and design teams in Cognite. Prior to Cognite, I was with Microsoft, and I led all of industrial portfolio products in Microsoft, including Azure Digital Twin, Azure IoT, Windows IoT, and Azure Percept AI. Prior to that, I built Samsung's internal and external facing IoT platform. And prior to that, I worked for Amazon and AWS. All right, so let's get started. This is the typical industrial environment. We have a bunch of assets. We have a bunch of processes. and we run a production. And the way we build the data foundation that Michele talked about is we onboard the data. We have a set of data sources, P&IDs, equipment data, sensor data, which is time series, ERP and SAP, work orders. We have images, we have 3D models. Then we want to make sure we give this some context. And this context is basically saying this valve is connected to this pump, and this pump is connected to this pipe, and this pipe is connected to this storage tank. Now, when the time series data come in for the pressure on this pump, then we can overlay it, and all of a sudden the combination of these two, what we call knowledge graph, it represents a live version of your physical world, the plant, the refinery, the drilling site, you name it. And then we build a bunch of APIs on top or applications to address different use cases. This is how typical data, basically foundation or data ops value chain work. Now, generative AI is disrupting and adding value all throughout these three layers. We are using generative AI now and LLMs and various types of multimodal generative AI for data onboarding, from understanding what P&IDs are doing to understanding service manuals and repair manuals, you name it, and time series even. Even contextualization, we leverage generative AI to create the graph itself and to overlay and map the data on top of it. And obviously the data exploration part, which is a no-brainer because now applications are turning into a natural language sentence. Just think about it. All of the software engineering that we used to do to build applications, now we are replacing it by an English, Chinese, a German, Arabic, you name it, sentence. And this is fundamentally changing the reach of technology in industrial environment and who is an application and use case developer. So major disruption on that topic. But there are some nuances when you want to leverage generative AI. And I want to talk about two key ones, which are very important. Michele said you need to trust your data. Well, LLMs, they sometimes hallucinate. And when they don't know the answer, they give you an answer, and they don't tell you they don't know the answer because they're statistical models. We call this hallucination. And typically this happens when you ask them a question about a data that has not been used in training the LLM itself. So let's have a quick example. This is a simple math. A 3rd grader can solve it. If I sold 10 product A and $5 each, and 15 product B, $3 each, and 8 product C, and it was $7 each, how much did I make? If you give it, this is actually a ChatGPT response, it gives you 141. The right answer is 151. And as a result, this thing was not seen as is on publicly available data on internet. So it was not used for training ChatGPT engine, and you get the wrong answer. And it doesn't tell you that. I don't know. It gets the equation right, but it gets the answer wrong. So basically, the real solution to solve and address this problem, to allow the large language model, which is the biggest part of generative AI revolution right now, to understand your private data. And the way you do it through retrieval augmented generation, and you do it through codified context. And codified context is where you capture the relationships, as I mentioned, your valve, your pump, and your tank in the physical world in a graph, and you overlay the data on top of it. And that will allow the LLM to query and interrogate the knowledge graph and gets the right answer and come back with the right answer to you. And if it doesn't know the answer, the graph will tell the LLM that I don't know the answer. And as a result, you get always a reliable, trustworthy response. This is the overall typical architecture, a variation of what Michele showed. Basically, as you can see in the middle, we have the LLM, we have the RAG architecture, all of the data, your private data sources are coming in, are provided to LLM at the time of prompting the LLM, at the time of querying the LLM. and your industrial knowledge graph that captures the relationship of your data sources in the physical world also are there. And then you can basically surface it in your user environment that the user, in our case, it's industrial canvas or Copilot. Those two experiences allow the user to basically leverage LLMs to interrogate these layers of data. Now, why is this also, there is another issue with LLMs, and why is LLMs not quite ready for prime time for industrial data? The other one is basically the economics of it. This is a typical neural networks this is like circa 1995 when I was a PhD student. You have the input layer, you have the hidden layer, 1 and 2, and you have output layer. About 32 parameters. Each of these arrows are parameters. They're a weight. And every time this neural network wants to classify something to give you an output based on an input that you put in, it has to basically go through evaluate all of these parameters. So 32 in this case, not too terrible. We can handle that. But when you come to where we are today, for example, in 2020, the transformer models, which are the basis of GPT. GPT stands for generative pre-trained transformers. These are hundreds of layers. For example, GPT-4 has 1.8 trillion parameters. Every time you ask an LLM a question, it needs to evaluate 1.8 trillion parameters. And that requires computation. That requires GPU time. And GPUs are very, very expensive. For example, this little calculation, 10 multiplied by 5 multiplied by 2 takes 1.8 trillion calculations with GPT-4. If you want to do it just on a regular CPU, it probably 3-4 machine cycles. So you see the difference. And this adds up very quickly into millions and tens of millions of dollars flat cost. So what do? You capture the data in a knowledge graph. This is a typical knowledge graph. You have the graph, you have your assets, and you have your processes all embedded in the graph, and the relationships are captured, and the data are overlaid. And what I'm talking about is not just for industrial environments. This is practically anywhere you query an LLM for any type of data, even when the data is available. So even when hallucination is not a problem, economics is still a problem with LLMs. For example, what was Obama born? Answer to this question is 1.8 trillion calculations, again. And depending what part of the data, what part of the country's data was used to train the LLM, predominantly, was it in the coasts of California or New York, or was it in the middle of the country? You may or may not get the right answer. The same for industrial data. What pump model do I have that used this type of gasket? Again, very likely in your specific private domain data specifications are not available publicly on the internet. As a result, you're still going to use 1.8 trillion calculations to get to some answer. You don't know whether it's right or not. And there is a good chance that it's not. So knowledge graphs solve this problem too. We talked about how knowledge graphs solve the hallucination problem. Knowledge graphs, if they don't know the answer, they come back and say, I don't know the answer. So as a result, LLM can tell you so. But look at this bottom left of this screen. 1,000 queries costs $7.50 on Azure ChatGPT 3. The same 1,000 queries cost orders of magnitude, 15 cents in a large knowledge graph set. It's just computation, the less number of computation. So you see all of a sudden, your cloud cost that with a combination of knowledge graph and LLM that will cost you $1 million a year can easily become $50 to $100 million a year if you don't use knowledge graph and you just use LLMs, even if you fix the hallucination problem. All of a sudden, this is orders of magnitude cost difference. So 2 reasons: accuracy and hallucination, and economics and computation cost. That's why I called the title of this presentation, The Magic Happens When You Combine Knowledge Graphs and LLMs. Another example about when the proprietary data is not available. Some of these, how many pressure transmitters are there on my plant? This is counting. LLMs are not good at counting. The second one, give me all the work orders that took longer than estimated time to complete. This is real-time dynamic data. Again, this is not something that LLMs are trained. LLMs are trained for with static data, not dynamic data. Find the pumps from Siemens that had inlet pressure of this spike of 80 bar in the last 4 months. Again, dynamic data. So all of these are examples of very valuable queries that you cannot rely on LLMs alone to get the right answer. This is how a typical LLM basically chaining works. We call them agents, but these are really software entities that embed the large language models. Let's look at the top query, which is the user question. What is the design pressure of this pump? Now, what happens next is the LLMs goes and finds out which asset does this question refer to. What is the design pressure of it? And then that generates another prompt and goes to the knowledge graph, and then goes back to the language model, and then it retrieves through the API from Cognite Data Fusion, which is we call CDF for short here, and it retrieves the information. Then prompt B says, answer the question below based on this content. What is the design pressure of this content, this document that came from the previous language? And the design pressure comes back as 90 bar. And the reason design pressure comes back at 90 bar because the pump had a node in the knowledge graph. This pump had a node in the knowledge graph. And the knowledge graph had another node connected to it, which was the specification document. It was a PDF and it was contextualized. And that information was readily available in the knowledge graph for the LLM to go and query. LLM here, what we did, we used a series of LLM prompts that each time LLM generated code, in this case GraphQL, which is similar to SQL for databases, goes queries the knowledge graph, comes back with the answer. Goes queries the knowledge graph, comes back with the answer. And those answers are already available because we've done our work before to build that foundation, the data foundation that Michele was talking about. So if I want to wrap it up, LLMs are wonderful, but they overfit for maximum likelihood. They're a statistical model. And as a result, they hallucinate. They give inconsistent answers. Sometimes they give this, sometimes they give that. And you've probably experienced it when you use ChatGPT. And they're economically very expensive to run. And the reason is they're neural network models. You do basically inferencing, machine learning inferencing every time you query an LLM. And they're difficult to audit and trace. They're almost like black boxes. Which, going back to what Michele said, that we operate in a highly regulated environment. And as a result, we need to be auditable and traceable. That makes it difficult to stay compliant. Knowledge graphs, on the other hand, they overfit for truth. If they don't know the answer, they come and tell you, sorry, I couldn't find what you're looking for. As a result, they don't hallucinate. And they always give the same answer. They provide you with consistent answers. They are inexpensive to run significantly comparative to LLMs. They're easy to edit and fix, and they're fully auditable. So you put these together, you can machine learn Obama's birthplace every time you need it, but it costs you a lot if you use LLMs, and you never know whether you got the right answer or not. So with that, I conclude my my talk, and I give it back to Gabe, back to you.
Thank you both, Michele and Mo. I think this is really, really interesting. I learned something new as well around the Federation. So great context. I'd love to kick off some Q&A. So for the audience that's listening, if you've got a burning question, we'd love to go ahead and put that in the chat box, the Q&A chat box, and we will address it. I did see a few questions ahead of time come from some of the pre-registrants. One was really probably more for you, Michele, and it was really around who are the main stakeholders involved in buying and deploying data ops. It seems pretty complex. Could you maybe share a little bit of light on that, Michele?
Yes. And first, I'm apologizing. I don't know why it's not letting me. Oh, there it goes. Okay. Nope, it's not. It's not letting me come back on video. Okay, to answer the question is we're still seeing it come from within a lot of the data teams and the architecture teams. So roles will be either at a higher level, an enterprise architect, or maybe a specific data and information architect. We're also seeing it come from the engineering teams themselves, the managers and leaders of those data engineering teams. Now, if it's a little bit more operational technology, there will be members who are, living within the operations teams, and who are responsible for those systems. So they may have a say or be involved in the decision process, but generally it's still within the data teams.
Gotcha. Thank you.
Did you hear me?
That was,
yeah. Okay.
I can hear you. Had another question here around where is the human in the loop, both from a knowledge graph perspective and an LLM perspective. Mo, that might be a better question for you. Any thoughts there?
Sure. That's a great question, by the way. So it depends the level of maturity of the solution that you've built. Early on, you want to make sure humans are more involved and they audit and they observe the results and the generation of queries and questions and documents that are coming out of your data flow that includes LLMs. Then if one of the ways that we help to automate this further is we have a machine learning model to learn from the human in the loop, the observer, the auditor. And over time, this machine learning model becomes better and better and can detect many of the deficiencies or errors that the data flow generated that the human in the loop operator caught. And as a result, the human involvement becomes less and less. But for example, we have a use case right now for one of our customers that we generate work orders automatically. LLMs generate work orders for maintenance engineers and maintenance technicians. You don't want just early on as you're deploying this for the LLM generated work order to just dispatch people. You want to make sure the shift supervisor or somebody in the loop is looking at the work order, saying this is okay, this is not okay, and that this is okay, this is not okay becomes a training cycle for a machine learning engine. And over time, the whole flow becomes more intelligent and less dependent on humans.
Gotcha. No, that makes a lot of sense. Michele, I had a question come up for you as well around, this whole data ops methodology is evolving pretty quickly. Could you maybe share a little bit about, what's different now than where it was, I don't know, 5 years ago? What are the biggest changes, and where's there been the most progress?
I think the first spot is that it wasn't data ops originally. It was data management teams kind of bolting together a data lake or a warehouse and, making sure that all the data would dump into there. And then they say, here, it's yours, open it up, do what you want to do. And, we've done that for decades. That's kind of how it worked. The frustrations of the analytics teams and the business teams of not being able to work with the data meant that, the notion of governance and trust and quality of the data started to race to the forefront, because you dump data into something, it doesn't in context of anything that you want to be able to do. So the governance piece started to raise its head as well. And I think, the evolution had been that if you can start to bring together why you want to use the data with how you want to technically manage the data, you're going to get better. And so that's kind of where data ops really started to pull itself together, which was creating assurance that information was ready to use, and having more bi-directional involvement with subject matter experts and stakeholders. Today, it's even more, it's changed even further, because the data teams are now having to recognize that they need to manage information as it flows. our operational systems, and certainly within our industrial sectors, have put pressure on the fact that data is moving all of the time. You can't wait for like a system to update and capture it all and say, okay, in 24 hours, I'll give you your results. I could have a production line go down or a wellhead go down, and I can't wait a day for that to get fixed. That's millions of dollars. And so now data engineers and data ops in particular have to be on top of this. They have to recognize those signals, contextualize those signals. And it means that they're really thinking much more about solutions. And certainly, if you can move data ops in that direction, being part of solving business challenges versus just provisioning data, you are not only providing more value to the organization and demonstrating data value, but you're also better positioning yourself for this world where we're now in an even more dynamic conversational environment as we move to generative AI. I just want to say one thing, though, to add to Mo's comment earlier about human in the loop. In a regulated industry, it becomes really important that human is always in the loop. The regulators are always expecting that there is human oversight and determination whether you use information or whether you don't use information. Using capabilities like knowledge graph to kind of set and constrain the data so that you have interpretability and lineage analysis and observability of that environment is really, really critical. So this notion of data ops and why we see even the shift into operations more and more is because regulators care about the decision. They don't just care if the quality of the data is there or not. They want to know how you're using it and how you're taking advantage of the analytic models to perform. And if you are just letting it go and not paying attention, it's actually demonstrating that you're not adhering to not only the spirit, but the law that has been put into place.
Yeah, I loved your point earlier on where you said it doesn't matter what comes out of the model. You're still on the hook for the decision, right? I think that's nuanced, but also very, very important to pay attention to. We've had a few other questions come in here. So I've got a question. What level of quality is required in foundational systems and data feeding LLMs and knowledge graphs? Thinking about prereqs, metering, instrumentation, and correct calculations for process data and the accuracy of PNIDs. So great question around data quality.
I can add a little context there. So this is obviously data quality has always been one of the most important, but also most challenging parts of building a data foundation in any enterprise or industrial environment. The good news is that we used to drive a lot of checks and balances to make sure data quality is measured and is met also for what we're trying to do by human operators. The rules and the rule engine that we said, is this piece of data complete? Is it relevant? Is it recent? All of those timeliness and other data quality metrics that we have. Now we can use LLMs, and we are using in Cognite LLMs to generate those rules. So all of a sudden, data quality that used to be this enormous undertaking, important but enormous undertaking, is substantially easier to accomplish and achieve. Great question. And again, there is good news here because of GenAI.
Michele, do you want to add anything there? Any best practices you've seen from some of your clients?
Yeah, it's really interesting. I mean, the old adage holds true of, quality is in the eye of the beholder. You have to know your business metric framework, because that's going to determine whether data is at the right level of quality versus not. I mean, there's usually things that are very obvious when there's, you're expected to have perfect data in scenarios where there's, a higher risk. And then there's areas where maybe the data doesn't have to be perfect, but you need to be trending. So, certainly as you're watching your time series data, there could be issues that come up where there's a glitch in the network, and so you're losing little bits and bytes, but you've sessioned the data in such a way that it's still highly reliable. But how did you make that determination? It's because you knew what the level of frequency you needed to have confidence of whether something is working or not working. So, really, just to add to what Mo was saying, which she's absolutely spot on, just that added layer of what is the use case, what are the business metrics that are associated to it, and understanding the relationship and correlation between good quality data and bad quality data on the impact of that outcome.
Yeah, no, absolutely. We have another question here. Could you describe why it is difficult to create meaningful relationships among industrial data? How transferable is the industrial knowledge graph across heavy asset industries?
I can take a first step at that one. Look, at the end of the day, when you want to, let's say a time series is coming in, it's from some assets, and it's about the pressure of this asset. A human user may know this is coming from this Siemens pump, or pump with Siemens automation. Now, when you have thousands of assets, sometimes tens of thousands of assets, typical large-scale industrial environments have sometimes over 1 million, 2 million data sources, it's hard to figure out which is which. And the way you typically have figured it out in the past is you go through your PNIDs, the documents that describe the design of the plan. And as you guys who operate these environments very well know, there are many versions of one PNID. Over time, they've evolved. And which one is the latest one? And then there are overlaps. This PNID describes this part of the plan. This PNID describes that part of the plan. So it takes an enormous amount of effort to figure out what, first of all, what the structure of the physical world is, who's connected to who, and then to overlay the time series, the near real-time data on top of it that say this time series is a pressure, represents a pressure and belongs to this particular pump. And that typically has taken a year, 2 years in a very typical environment. Now we're leveraging computer vision and a set of multimodal generative AI functionality and capability to read those PNIDs and documents and diagrams and texts, and to comprehend what is exactly connected to what. And then we have other machine learning models that have been trained to detect the pattern of a Siemens automation versus ABB automation versus Rockwell automation, as OPC08 tags are coming in, for example. And now we can, and through those, we map, or we at least suggest with 80, 90% accuracy, this time series is for this asset. So things that used to take years now are taking weeks and months at most.
Yeah, no, Michele, anything
to
you
add
want
to that, yeah, no, it's interesting. I totally agree. There's also sort of this other side of it, which is, we're living on top of legacy upon legacy upon legacy of code, where the documentation is gone, the people are gone, meaning that they probably working somewhere else. Be mindful of that. But it's interesting because, one of the bigger use cases within, technical teams right now is pointing generative AI towards old code and redocumenting it. And so the things that, that you can infer from that help you build back an understanding of how these systems were crafted, how these pipelines were crafted, how the data was being defined. And now you can start to rebuild and reconstitute that data to the point of not only as like, what should the quality standards be, but also the interpretability, so that you can get it into the hands of, well, is that data connected to that sensor on that pump, on that rig, for example? So, it's kind of cool that you can kind of address it from both sides, where before you would have to hire or even find the experts that understood how to go on that archaeological dig and work in a lot of code that most people are not even using anymore.
Yeah, no, great. I think we're going to go, I don't have any other questions here. So I think we'll go ahead and maybe wrap up a little bit early, but I really appreciated the discussion. We will send out the presentation after the fact. And again, Michele and Mo, thank you so much for your insights and for the content today. I thought it was really, really valuable. So thank you everyone for joining us. We'll follow up.
Thank you. Cheers.
Thank you.